There you go. So the official name, what we're doing is we're solving for y. Unofficially, we could call it something like turning ugly ghetto equations into good equations. What makes an equation good is that it's just ready to graph. You don't have to do any math. So for example, if I gave you an equation like this, you're like, thank you. That's the easiest thing you've ever asked me to do. You go down four, put a point, and then you just go up to right three a couple times. You got yourself a line. Super easy. So the purpose of today's lesson is to make equations that don't look like this look like this. All right. And another example would be, if I gave you an equation like this, you're like, oh, thanks. That's easy. I just go make a vertical line at 5 on the x-axis. Piece of cake. Or if I gave you an equation like this, you again say, thanks. Thanks for the free points. I just go down 2 and put a horizontal line. So this is the goal for the day is, can I make my equations that do not look like this look like this? Okay. Pretty important skill, super uber useful as far as making your math life easier. So let's knock out a few and then I'll hand out the notes page. I just kind of want to get you cruising before we look at the piece of paper that I have for you. So here's an example. This is in a different form. I don't really want to go into details about what it is. It's called standard form. And there will come a day when we'll actually graph equations directly from standard form, but today's not that lesson. I don't want to go down that road. I feel like we're in a week or so right now of our lives together where I'm just trying to really focus on, here's an equation, make a graph, like real easy slope intercept kind of understanding. So what I want to do when I'm done is I want to make this equation, since it's got x and y both, I want it to look like this, right? That should be the goal. You should say, I would like to graph this line because it's literally, it's a walk in the park. Piece of cake, right? So, Jojo, I see your hand just loitering there. What's up, bud?
Good question.
Sure.
What would we do first? Would we subtract 4y?
Well, that's kind of what I was going to get to, was what do we do first? So before we begin, I want to make sure you're all perfectly clear on the objective and the purpose. The objective is to get y by itself. The purpose is so that I can make a quick and easy graph without having to do any math. So this is going to involve just some basic algebra. And your idea now is to go back to what we know about equations and say, if I want to get something by itself, I simply have to move all the things that are with it away from it. We've been doing this all year. We started this in our first week together back in August. So my target is eventually to get y by itself. I cannot get y by itself until I get that red brick by itself. So your first objective is not even to think about the 4 that eventually you want to destroy. Your first objective is to pick up this 3x and move it to the other side. Because we got to clear him out. Now, you can't just do that. You can't just pick something up and move it. But what you can do is you can subtract it on this side to make it go bye-bye, and then subtract it on this side, because that's what mathematicians understand the law says. If I do it on the left side of the equal sign, I have to do it on the right side of the equal sign. Fair's fair. So over here on the left, I'm going to destroy these, leaving my positive 4y by himself. This is good news. Now, in order to meet my goal, I want to be aware of what I want it to look like. Remember, I want it to look like this. And so I want to pay attention to something. I want to pay attention to the fact that we like it, whether we know it yet or not. We like it when x goes first and the hangy outy y-intercepty number goes second. You have control over that. You have control over the order in which you write your terms. Having said that, the way I'm going to write W-R-I-T-E, the right, R-I-G-H-T side, is I'm going to very purposely put the negative 3x first and then follow it up with the minus 20. And if you're wondering, well, why didn't I just put like negative 23? Well, the answer is because I can't. Those aren't like terms. You can't put something together that has an X with something that doesn't. Do you have any questions so far? Bless you. We're one step now away from our objective, our goal. Our goal, remember, was to get y by itself. So now we have no choice but to go kill the 4. And what operation will let us kill the 4? Division. Sometimes in math, if you want something to go away, you add it or subtract it away. But when it's attached to something else that you want to get by itself, the only way in math to pry it away is to divide. So check out this step. I'm going to divide by 4, but because division and multiplication are the same thing, like, I know it's weird. You can distribute division, excuse me, you need to distribute division the same way you distribute multiplication. So I am not going to put one big division sign on the right-hand side. I'm going to put a special division sign here and a special division sign here. Each term is treated separately from all of the others. And now, when I cross out these 4s, I'm there. I made it. I have y equals. Now, in this gold green box sits our buddy. What's his name? Who's right there? It's called the slope. We know that the slope is always in a predictable place. It's always the number that's multiplied by x. So my slope appears now out of nowhere as -3/4. We now know that the graph will go down 3, right 4 when we get around to graphing it. And then who's this fellow over here in the purple box?
Down 5.
Who is he? He's the y-intercept. So what we're doing here is we're rewriting the equation so that the slope and the y-intercept will just pop out and say, here I am. And now when I say to Austin, I need you to go graph this line, he's like, oh, I got you. That's easy. He just makes a graph. He goes down 5, puts his first dot, and then goes down 3, right 4, up 3, left 4, and boom, he makes a line. And that's how easy it is. Had I asked Austin, hey, Austin, I need you to graph this line, he'd go, oh, I don't know where to start. I get it. And that's why we do what we do, is we make equations look the way we want them to look. And we have the skill set to do that. We're just moving things around, adding x's, subtracting x's, moving y's across if we want to. You can put things wherever you so desire. All right, let's go again. Let's do -2x plus 4y equals -4. You want to get good at this. I mean, you may not want to, but as someone who's stuck in high school for another few years, you're going to want to be good at this. Really good, like perfect at this. Like breaking down square roots. It's kind of one of those things. What do we do first? We agree that we want to kill this term, correct? How do you eliminate a -2x? You add, and I heard a couple of you say add negative. Do not add a negative. That's counterproductive. You add regular 2x. Job 1 is to make sure that there are no remnants of that guy. And then, to not anger the math gods, you would go to the other side of the equal sign and you would add 2x over there as well. It's the number 1 rule of algebra. You do it to one side, you do it to the other side. So what I'm going to do now is I'm going to cancel these out and I'm going to flush things downwards. I'm going to first flush down this +4y. I'm going to flush down my equal sign. And now the order in which I write the right-hand side, I think, is important. What should I put first? The +2x. And I don't need that plus sign anymore. That'd just be weird. It's positive. We're good. And what goes after that? Correct. Feeling it? It's our last objective.
Divided.
Divide everything by 4. And remember, please, that the division occurs everywhere. It is not a one and done thing. It hits boom, boom, boom. Everything it can see, it divides. So we cancel these, drop your y, drop your equals. And what is my slope? Correct. 1/2. X is not part of the slope, just the half is the slope, minus 1. And again, if I say to you, hey, could you please go graph that line? You're like, yeah, I got you. You go down 1, put a dot, and then you go up 1, right 2, up 1, right 2, and boom, you got yourself a line. Graphing is easy when the equations look a certain way, hence our desire to make them look that certain way. Okay. You can also do this. Well, here, let's do one with a negative. And then I'll show you the verticals and horizontals, and then I'll hand out your note sheet so we can feel a little better starting it out. Job 1. Minus 5x. Okay. No talk of negative. You're just either we're adding or we're subtracting. Let's keep math as easy as we can. That's a positive 5x. I shall subtract 5x. Simple subtraction. Clean and easy. On the right-hand side, I also will subtract 5x. I will cancel and I will flush straight down. We always flush with equations. You know, I'm big on that. Your equal sign should always travel a vertical pathway because we're just flushing down, 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 down. What comes down on the left side? Negative 3y. This thing with the white arrow up here at the top, the 2 arrows pointing at it, used to be called a minus, but when we murdered what was in front of it, he now changes roles and becomes a negative. And then the right-hand side, what am I going to write?
Negative 5x minus.
Correct. And now comes the final step, where we divide, divide, divide.
Divide by positive or negative?
You tell me. We divide by negative. If you want to get the job done that you came to do, you need to divide by all of the number that you're trying to unalive. You want to kill a -3, you better divide by another negative to make the negatives go away. So the -3's cancel, and we're left with our answer, which is y equals what? What's the slope?
5.
The slope becomes positive because the negatives, I'll put red circles around them. Those negatives, when they divide, of course, become a positive. So we have y equals 5/3 of x. What's the y-intercept? Correct. And again, graphing, easy. Go up 7, put a dot. Go up 5, right 3, or down 5, left 3, whatever floats your boat. Okay. We can make math easy if we have skills like this. Finally, there are equations that only have one variable. So it should catch your attention if I write an equation like this. If I say graph that line, the first thing you as a student note is that there's no y. And in your notes, you wrote this down. It was probably a week ago, but you wrote in your notes, if there is only an x, what kind of line is this going to be? It's going to be a vertical line. So our thinking isn't get y by itself. That would be really weird because there is no y. Like, how could you get y by itself? So this is the only time where our thinking changes to, well, since there's no y, I guess I'll substitute and get x by itself. So it's a little different of a vibe here. What are we going to do first? Follow your math instincts. Yeah, let's eliminate that 5. So we're going to subtract that 5 across like this. And we're going to get 3x equals, what's -7 minus 5?
Negative 8.
Negative something
12.
for sure. -12. You almost had it. Right. And then if we divide both sides now by 3, because, we got to finish what we came to do. If we divide both sides by 3, then we're left with x equals what? And now when I say graph this line, you're like, I got you. You'll go left 1, 2, 3, 4, make a mark, and then you'll graph a vertical line. And the same can be said for y's, and then I'll conclude this part and we'll get going with our, we should cook through the notes page pretty quick, having started like this. So there are also going to be equations that don't have x's, like this. So let's say we had like negative 2y equals 11. As a student, you have to create associations. That's what the mathematician does, is mathematicians look for how can I relate something to something I already know. And your job is to look at this equation and say, this is worth noting. There is only a y. And what kind of line has only a y? A horizontal. So we know going into this that our line is going to look like this. We're not going to panic. We're going to get y by itself. And how do we do that? No, we divide by -2. And I did this to you on purpose because I want you to be prepared for the fact that not everything comes out clean and pretty. You know the answer is going to be negative. What is 11 divided by 2? It is. It's 5.5. And I'm always telling you guys from all of August through November, I'm always saying no mixed numbers, no decimals. Today's the day when I finally say we want a mixed number or a decimal because, as you'll see, when I go to graph this, and so I'm just sketching just like you would in your notes right now. I know it's a horizontal line, right? And I say to myself, well, how am I supposed to graph that? It's like, it's not a whole number. That's okay. So we're going to make little tick marks on our graph. We're going to go down to -1, -2, -3, -4, -5, -6. And you're smart. You say to yourself, where is -5.5? Well, it's halfway between -5 and -6. So on a graph, I would just simply go halfway in between the two grid lines, and then I would make a line horizontally right through there. We're not going to panic. I'm asking this of you. We're not going to panic when these things happen. We're going to accept the fact that sometimes our intercepts are going to be things like 3.5, 5 1/3. And when that happens, we're just going to estimate where they are. I know where -5.5 is, and so do you. Okay. All right. So I'm going to pause this. I'm going to hand out our notes. Let's crack through it just super quick. And then we'll get to work. So the first thing I think we should all do, and again, I apologize for where these are. I couldn't move them. So I'm just going to take the equation and move it down to the bottom so that I can have a place to show work. So you should do that as well. All right. So yes, this one is as easy as we think it is. There's only really one job to do here. How are we going to get y by itself? Absolutely not.
-1.
Absolutely double, triple not. Yeah, listen, clearly something did not go right in the last 10 minutes. I need you to understand this. Look at the TV. This 3x needs to go away. Not divide, but he's detached. He's his own thing. He's separated from the y by a plus sign, which means he's not a division thing. He's a get rid of me by plus or minus. And since he's positive, we will subtract 3x. I heard some things there that made me take pause and go, whoa. So when I subtract 3x, I'm actually done in this case because the y is now by itself. How will I write the right-hand side? Perfect. And that one is done. So since you've got a ruler and I gave you a place to graph, let's graph it real quick. And so what we're going to do is we're going to go up 4 and put a dot. And what's our slope?
Down 3, right?
Perfectly spoken. Since it's negative, we got to make sure if we go down that we turn to the right. You should always graph as many points as your graph will allow. And then grab your ruler and make a line. And remember that your lines should go out. You don't have to be obnoxious about it. And then arrows on both sides. Okay. Let's head over to problem number 2. And again, let's just take a quick moment and copy it down. And hopefully the answers that I hear this time are a little bit more quality. So let's try again. What should we do first? Yes, remember the 2x is a detached entity. It needs to be physically picked up and moved, like with a forklift. And so we are going to add a copy of himself to make him go away. And then that's going to leave us on the left-hand side with our positive 3y. And how are we going to write the right side? 2x minus 6. And now we're poised to finish the job, right? And the job completion is to divide by 3. And remember, everything the division can see, it will divide. It's not a one big division sign. It's in everything. What will our final answer be? Correct. And now it's graph go time. Where do I begin my graph?
Down to
Correct. And what's the slope? Talk me through it.
two here.
Perfect. And I do have enough room, as do you, to do that twice, but I want more points. So I can reset. I can go back to my home base, my down to home base. Where else could I have gone?
Or down to three.
Correct. Going down and back to the left creates the same tilt as would going up and right. And so again, we grab our rulers and make a line. Make sure your line goes out both sides. Slap some little arrowheads on there, and we're on to number 3. Number 3 is the first one where you might feel a little bit tricked. So let's just have faith in our skills. We have x minus 3y equals 9. Who has to go first? Move that x. And since it's a positive x, how do we murder it off? With a minus. So we're going to just minus x minus x. That negative 3 should be off limits. It is attached to the y. We will deal with him last. So a positive x is eliminated by subtracting him. That's what we come to know as moving it to the other side. We're going to start using that language more and more now in this last 5 months, 6 months of the school year, whatever. What will I bring down on the left? Negative 3y equals. And how will we write the right side?
X plus.
This is usually where I get a lot of questions. So for those of you guys that have dozed off and are taking a nap right now, just some friendly advice, you might want to listen. I get a lot of questions about this. Not what to do. Everyone knows what to do. Like I'm not even going to ask because I know you know. We're going to divide both sides by negative 3. And when we divide, it looks like this. That's not what I get questions about. It's this next part. What's the slope?
Third.
Yes. And the question that I get is because, and we talk about this all year, no matter how hard I try to avoid it, you can see that little green arrow. What number is it pointing at?
1.
There's a 1 there, right? And when you visualize that that's actually a negative 1 being divided by a negative 3, that's where the slope of 1/3 comes to exist. That darned invisible 1. It's always kicking our booties. And then the back end is just basic, like 6th grade division. What is a positive 9 divided by a negative 3? So our y-intercept is minus 3. Whenever there's not a number with x, watch out, because there is one. We just don't, math people don't write it. I'm not going to start writing it because then you're going to get to classes where people don't, and you're going to feel like ripped off. So yes, it's there. All right, let's graph this little sucker. Where do we start? Down 3, not negative 3. Down 3. And what is the slope?
1.
Correct. And you have enough room to make 5 points. You have your y-intercept and you can make 2 on either side. Oops, I went up too far. That's my apologies. There we go. That's better. And then where else could I have gone? Down and left creates the same exact slope as going up and right. And then you make yourself a nice, beautiful line using that nice straight-edged ruler. Have it poke out both ends, slap some arrows on it. Number 4 is our first foray into we're not going to panic. What's the first thing you notice about problem 4? There's no y. It's going to be a vertical line. So I've got this equation, and I'm not going to walk up and say, I don't know what to do, because I'm listening right now. We're all paying attention. We know that when there's just an x, we're not going to panic. We're just going to get x by itself. And how do we do that? What's our answer? Done. And we know from practice that lines that look like this, equations that look like this, produce lines that look like this. Should those be the easiest problems? Yes. Are they? I know, and I don't know why that is. Like slope, it vexes me. How could that be something that becomes more difficult? I don't know. It's weird. Back page. Let's head on. Number 5. Step 1, let's copy that little equation down to the bottom. So we got a 10 minus 2y. What do you notice about problem 5?
No.
There's no x. So what kind of line is it going to be? It's going to be a horizontal line. So let's do some basic algebra. How do we get y by itself? Minus 10. Good. Because that's a positive 10. What will my next equation say?
2y equals -3.
Thanks, Rowdy. Perfect. Negative 2y equals -4. And then what do we do to finish the job? Yes, we do. We divide by -2, giving us our final answer, which is y equals what? We know that this is horizontal. We're not going to panic. We're just going to go up 2, and we're going to graph a line on 2. Oh boy, I got a little zooming issue here. Sorry, folks. These PDFs in this program just don't love each other very much, but I think that I pulled through a little bit there, right? Could I have about 1 more minute? Could you guys come back in like 1 minute? Thanks. Number 6, let's get this done. Okay, number 6, we're kind of back to the norm. Let's copy that equation down. What do we do first? We're almost there, guys. Let's do that. And how we write the right-hand side is going to keep us all together on the same page. You may at some point decide to start writing your right side backwards, and that'll be your prerogative. I just don't think the first day of doing this is the day that we should go rogue. So let's stay concrete together. We have -2y equals what? And then the final step, what do we do? Remember, we divide here, here, and here. We're done. We just have to not botch the ending. What's going to be my slope right here?
We have
Positive 3/2. Nice job. Remember, watch those negatives. And then what's my y-intercept going to be? It's negative. What's 7 divided by 2? Not 3/2. 3.5. 7 pizzas split between 2 people. Each person gets 3.5 pizzas, right? So when we go to graph this, where are we going to begin our graphing journey? Nice job, Rowdy. We're going to go in between -3 and 4. So I'll zoom in on this for you. So my y-intercept is right here. Okay, I want you to be prepared for the fact that this happens a lot. It'll happen whenever it's meant to happen. And what is my slope? So watch up here at the TV as I move. I'm going to use a word here. You're going to hear me say this word a lot. This point, I call it a tweener. So my thinking is this: if you start me on a tweener and I go up 3 and right 2, I'm going to end on a tweener. Every point that I graph is going to be a tweener, right? So I'm going to go up from here, kind of watch my pen. 1, 2, 3, 1, 2. Look, I'm on another tweener. You follow? And we're going to keep getting those tweeners as we continue our journey. Up 1, 2, 3, right 2. I can do another one. Up 1, 2, 3, right 2. So don't panic when your y-intercept doesn't come out all pretty like you want it to. Okay, I am not going to graph that line because I know you're just so over this and I want to get done. So you come back at some point and graph that line. Okay, please. Let's head on to number 7. I did this one because what do you notice about this maybe? I'm sorry, we're almost done. There's all the stuff is on one side, just FYI. So I don't want you to panic about this. What I did when I wrote these problems was I tried to say to myself, what's everything they're going to see on the worksheet? So that they don't panic and say, I don't know how to do this. So listen, here's your objective. See this red box? Get it alone. If I want it alone, who do I need to sweep away? Right, I got to get rid of everything. So I'm going to subtract 4x from both sides, and I'm also going to add 6 to both sides. Can I do two things at once? Yeah, there's no law against that. So on my over here, I'm going to subtract 4x and I'm going to add 6. Perfectly legal. I have two things I want to destroy. I'll destroy them both. I'm going to cancel these. I'm going to cancel these. What's my next line going to say?
3y equals -4x plus 8.
And look, now we're right back in our comfort zone. We've seen this before. What do we do? Someone maybe other than Embry want to answer a question here? I've heard like 2 voices today. Divide everything by -3. Good. So we're going to divide here, divide here, divide here, and we're done. We get y equals, it's go time. What's the answer? Cash it in. What's the slope? Careful. Switches to positive 4/3. And what's my y-intercept? And now we can make a graph. We could do it in our sleep. Go down 2, put your first dot. Talk me through that slope. How do you do a slope of 4/3?
Well, 4,
1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Other way, 1, 2, 3, 4, 1, 2, 3. That is a perfect slope of 4:3 ratio. It's a steep staircase. 4 inches up for every 3 inches you go to the right. If you built that in someone's house, they would request that you come back and rebuild, right? Any carpenter would tell you that's an unacceptable slope for a staircase. Okay, go ahead and graph that line when you're ready, and let's finish this off. And this last one, I really tried to trick you as much as I could. I'm going to work over here because I'm getting tired over there. So I have -6x equals 4y plus 12. Yes, sir. So what are we going to do on this one? Right. And listen, some people panic because the y is on the, I'm going to use air quotes here, the wrong side. That's not a consideration here. If you're one of those people who would panic in a case like this, before I do what you said, because I like it, you can take these sides and actually just swap them. Take a look at this. You could just write it as 4y plus 12 equals -6x. Learning algebra is hard, and it helps when we can put ourselves in a situation that looks like where we've been before. So just rewriting it like this, I think it's worth it. Now there's only a couple things to do. Now I'm ready to hear what you said about the subtracting 12 from both sides. I like that. My next line's going to say 4y equals -6x minus 12. What's my last step? Divide, 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 cancel. What's my slope?
no, 3, 4, oh, no, 3 over 2.
Negative
Yeah,
3
negative 3.
halves, and slap an X on there. And what's my y-intercept?
Negative, or down 3.
-3. So this is your finished product. That's your prized possession. That's the target for today's long lesson is, can I get these equations to look the way I want them to look? So we begin the graph by going down 3, and then we just manipulate it to look negative. If the line is negative, you better look downhill. You should be policing yourselves. and never accepting getting this wrong. Downhill and uphill are things that we should never throw away those points. So I'm going to make a ratio of 3 to 2. So I'm going to go down 3 and then I have to step right 2, or I could go up 3, back left, up 3, back left, up 3, back left, like that. All right. I know that took a long time. What I'm going to do is hand out the assignment. We're going to work on it for about 3 minutes. And then tomorrow will just be a work day for that assignment plus probably some more. Okay. So sorry that took so long.
Okay,
Mhm.
you have to mark more dots.